Hello students, we have already studied a lot about potentiometer. Now we will solve a few problems based on this concept. First question is calculate the value of the unknown potential V for the given potentiometer circuit. This is the circuit given. We have to find the value of unknown potential. This is V. The total length 400 centimeter of the potentiometer wire has a resistance of 10 ohm. This total length is 400 centimeter and its resistance is 10 ohm, and the balance point is obtained at a length of 240 centimeter. Balance point is obtained at 240 centimeter. So what we have to calculate? We have to calculate the value of unknown potential. This unknown potential will be, as per our knowledge, V must be equal to K into L, where K is potential gradient. So we have to find out the value of this K. So how to calculate K? K is potential drop per unit length of this potentiometer wire. Its length is given, that is 400 centimeter. So how much is the potential drop across length A and B of this potentiometer? For that we have to calculate the current flowing through it. Firstly we will forget this part of this circuit. This unknown potential will forget this galvanometer, everything. So how much current is flowing through this circuit? That current will be calculated as I is equal to V by V is 3 volt by total resistance of the circuit, that is 290 ohm plus its resistance is given as 10 ohm is equal to 3 by 300 is equal to 10 to the power minus 2 ampere. This much current is flowing through this 10 ohm also. Same current is flowing through this 290 ohm also. So how much is the potential drop across this? Potential drop across it is current, that is 10 to the power minus 2 ampere into resistance, that is 10 ohm is equal to 10 to the power minus 1 volt. Now what is its length? So its length is 400 centimeters. So we can find potential gradient. This will be equal to potential by the length, that is 400. This is volt per centimeter is the potential gradient. Now we know potential gradient, so we can find unknown potential. This unknown potential V will be equal to K, that is 10 to the power minus 1 by 400 into L. It is given that at the length of 240 centimeter, balancing point is obtained, means galvanometer is showing zero deflection. That means its terminal, its EMF, its potential is equal to the balancing potential of this along the length of this potentiometer wire. So this is into 240. So this, if we solve it, this will be 8 3 ja and 8 5 ja. This will be 3 by 5 into 10 to the power minus 1. This gives you 0.6 into 10 to the power minus 1, 0.06 volt. Another method, we can find drop, potential drop across it, that is what is the current? 10 to the power minus 2 ampere is the current into potential, 290 into 10 to the power minus 2, 290 into 10 to the power minus 2. This will be subtracted from 3 minus this will give you equal to 3 minus 2.9 is equal to 0.1 volt. 0.1 volt is the drop across this. This will be divided by the length, that is 400. This is again the same K. K will be multiplied with this 240. Same answer you will get. Another question, question number 2. Explain the principle of potentiometer. How can its sensitivity be increased? Why is it called an ideal voltmeter? These all concepts we have studied in our theory class. Principle of potentiometer is V is directly proportional to L provided I is steady and A is uniform. Means wire is to be taken of uniform area of cross section and steady current flows, then V is directly proportional to L. L is this. V is potential drop across its length. This is principle. How can its sensitivity be increased? To increase its sensitivity, what is required? K is to be lowered. As small will be the value of K, as sensitive, that much sensitive will be the potentiometer. It is to be lowered. So how can we lower it? We have already studied. L is to be increased. Increase L and decrease the value of current. I will be decreased. By following these two concepts, by increasing L and by decreasing I, we can reduce K, or we can increase the sensitivity of the potentiometer. That's why 10 meter long potentiometer is preferred over 4 meter long potentiometer wire. Next, it's why it is called ideal voltmeter. It is called ideal voltmeter because it is not drawing any current from the source while measuring its potential difference. So that in other ways, it is offering, this potentiometer is offering an infinite resistance in its path. So what is an ideal voltmeter? An ideal voltmeter is the voltmeter whose resistance is infinite. So it is acting as an ideal voltmeter. Next question, give two differences between potentiometer and a voltmeter. A number of differences are there. Number first, potentiometer measures the potential difference exactly or accurately, but voltmeter measures approximate value. And number second, potentiometer can measure internal resistance of the cell and the voltmeter cannot. And potentiometer is a bigger device and a voltmeter is a smaller device. Such a number of other differences also you can find. Question number 4. With a suitable diagram, discuss how the EMFs of two cells can be compared with the potentiometer. This we have already discussed. You can go through that. Next question, describe briefly with the help of a circuit diagram how a potentiometer is used to determine the internal resistance of the cell. That also we have covered. Next, two students X and Y perform an experiment on potentiometers separately using the circuit diagram as shown. What is the circuit diagram? Circuit diagram is this. This is the circuit diagram. Two students are performing an activity on this circuit diagram. What is first student doing? First student is X. X increases the value of resistance R. This resistance is connected here. X increases the value of R and Y decreases the value of resistance S. And other student Y does not change or does not vary it, but he changes or decreases the value of S in this setup. How would these changes affect the position of null point in each case and Y? Let us take first case. In first case, student X increasing the value of R. If R will increase, the potential drop across this resistance will increase. Therefore, the potential drop across the potentiometer wire will decrease because source is same. From this source only potential drop is here also, here also. If it will increase, drop across it will increase. So drop across this potentiometer wire will automatically decrease. That means K will decrease. K will become less. If K will decrease, this this potentiometer will be more sensitive. So at the point where we were getting balancing point or the zero deflection will not be sufficient to balance it. So its length will increase. It will shift to its right because the potential across this potentiometer wire is decreased because of increasing R. So it will shift to its right. Second, Y student decreases the value of resistance S. If S is decreased, what will happen? The amount of current flowing through this circuit from this cell will increase. So the potential drop which is required to balance this cell will be less. So this point of contact will shift to its left because less energy is required, less potential is required to overcome this. Current is flowing through it also, current is coming through it also. If more current will pass through this, so less length of the potentiometer wire, smaller length of potentiometer wire will be required to balance this, to get zero deflection. So it will shift to its left. Next question. What is meant by sensitivity of a galvanometer? A battery even of 4 volt and a variable resistance RH are connected in series with wire AB. AB is the wire and E1 is the battery of 4 volt, and the rheostat is shown connected in series with wire AB of the potentiometer. The length of the wire of potentiometer is 1 meter. Length of the wire of potentiometer is 1 meter. When a cell E2 of EMF 1.5 volt is connected, this E2 1.5 volt, it is connected between points A and C. Between points A and C, no current flows through E2. That means this cell is totally balanced by this length of the potentiometer wire. Length of AC is equal to 60 centimeter. Find the potential difference between the points A and B of the potentiometer. So this potential you have to find. This potential is given, this much potential drop is given, this much you have to find. Second, would the method work if battery E1 is replaced by a cell of EMF 1 volt? If this battery of 4 volt is replaced by battery of a cell of 1 volt, then would this method work? That we have to answer. Firstly, we will concentrate on first part of this question, that is find the potential difference between the points A and B of the potentiometer. So what is given to us? As per principle of potentiometer, V is equal to K into L. V is 1.5. This is overcome by 60 centimeter of this potentiometer wire. So K into 60. So what will be K? Potential gradient will be 1.5 by 60. This much what? Volt per centimeter. If this is K, then the potential drop across full length of the wire can be calculated. That will be V dash is equal to K L dash, and K is 1.5 by 60, and L dash is equal to how much? L dash is your full length, that is 100 centimeter. This will cancel, 2 5 ja, 2 3 ja, and this is 0.5 into 5 is equal to 2.5 volt. Should be the total potential drop across length AB. And second part, now we will focus on second part. Would the method work if battery E1 is replaced by a cell of EMF 1 volt? Had it been 1 volt, it would not be able to balance this cell of 1.5 volt along its length, because it is if we connect this jockey at point B, then also it will be 1.1 volt or less than that, because there will be certainly some drop across this rheostat also, so it will not work. So this will not work when we replace this E1 cell of 4 volt with a cell of 1 volt. So this is this question. Next question, let us focus on this question. A 10 meter long wire of uniform cross section area and 20 ohms resistance is used in a potentiometer. The wire is connected in series with a battery of 5 volt along with an external resistance of 480 ohm. If an unknown EMF E is balanced at 6 meter length of the wire, calculate the potential gradient of the potentiometer wire and value of unknown EMF E. How to solve this question? Let us try to draw the circuit diagram. What is question? A 10 meter long wire of uniform cross section, that is potentiometer wire AB, is having its length 10 meter and its resistance is given as 20 ohm. 20 ohm resistance is used in a potentiometer. The wire is connected in series with a battery. It is connected in series with a battery. This is battery of 5 volt. 5 volt battery along with an external resistance of 480 ohm. This is 480 ohm is this external resistance shown. If an unknown EMF E is balanced, let me complete this circuit. So this is potentiometer, this is auxiliary circuit, one key will be there. Now one unknown EMF E is balanced this is cell, its EMF is balanced by 6 meter length of the wire. Jockey is connected at this point. This distance is 6 meter. It is given. Calculate the potential gradient of the potentiometer wire and the value of a known EMF. Now you can do this. Potential gradient, how will we calculate? Potential gradient K is equal to drop across per unit length of this wire. So how much is the total potential? 5 volt will drop across 480 ohm also, across this resistance also. For that you have to calculate current. For measuring current, V is 5 volt, R is 480 ohm plus 20 ohm potentiometer wire resistance. This is 5 by 500 is equal to 10 to the power minus 2 ampere is the current flowing through it. So how much will be the potential drop across it? How much will be the potential drop across it? That you will calculate. That is V, let's suppose it is, and the total resistance is 20 ohm and the current is 10 to the power minus 2 ampere into 20 is equal to 20 into 10 to the power minus 2 volt will be potential drop across this potentiometer. What is total length of this potentiometer? That is 10 meter. It is of 10 meter long. If then K will be equal to V dash potential drop by its length. That is 20 into 10 to the power minus 2 by 10 is equal to 2 into 10 to the power minus 2 is equal to 0.02 volt per meter will be the potential gradient. And what will be value of unknown EMF? Unknown EMF means this EMF you have to calculate. That will be potential gradient into 6 meter. So it can be calculated as V double dash unknown, or E we have taken. E is equal to K, that is 0.02 into 6 is equal to 0.12 volt. This will be unknown potential. So other questions we will take in next class. Thank you.